function can have 4 turning points. Okay, true or false? What you got to say on that one? Ashley, what do you think?
False.
False. Okay, that is correct. Okay, that is false. So fourth degree function can have 4, 2, 3, 4 x-intercepts. It's always n minus 1 turning point. So it can have 3. Most it can have is 3. Okay, for that one. So that would be false. So you want to think, all right, can I draw it out? Can I draw a fourth degree function? Make every root have multiplicity 1 that has 4 turning points. All right, the graph of a fifth degree function can have no x-intercepts. No x-intercepts. Okay, we talked about this one a little bit with sixth degree, but what about fifth degree? Luke Campbell, what do you think?
I said true.
You said true. I'll go false. False. It has to have an x-intercept. So now I want you to think, why? Why does a fifth degree function have to have at least one x-intercept? What is the end behavior of a fifth degree function? Do they both go the same way or do they go opposite ways? They got to go opposite ways. So since they are going opposite ways, okay. Well, shoot, let me draw it different than that. Okay, since they're going opposite ways, so at some point it's going to have to cross the x-axis. Okay, it has to, because it was going from negative infinity to positive infinity. So at some point it will hit the x-axis. That would be true for any odd degree function. Okay, any odd degree function is going to open up opposite ways. Got to hit the x-axis. A fifth degree function can have one local max and one local min. Well, can you draw out that situation? So it has a max here. It has a min here. Well, the minimum degree for that would be third degree. But could it be a fifth degree? Yeah, fifth degree function. It can have one local max, one local min. Okay, what you can do is you can make it have multiplicity would be fine, but that would be case. So this would be true. Fifth degree function. Really, any odd function, any odd degree can model that. Okay, just based upon whether they're complex roots or whether there's roots of multiplicity. A fourth degree function can have a positive root of multiplicity 2, a negative root of multiplicity 1, and a complex root. Josh, what do you think?
False.
False. Because complex roots always come in pairs. So since they come in pairs, there would be 2 complex roots, 1 negative root, and you would count that as 2. So that would be 2, 4. That would be fifth degree. So that would have to be fifth degree. The way this is described. If it said a fifth degree function, then you could say yes. Okay, for that one. All right, so those are those 4 there. All right, it says find the zeros. If this is, let's say this is for the calculator part. Go ahead, pull out your calculators, graph it. Okay, if you are allowed to use your graphing calculator. What's that?
You just need a list of zeros. So you can say 1. Is it 1 twice?
Yeah.
1, and then 2 on this side and 2 on this side. You just say that. Okay.
All right, so graph that, figure out where it hits the x-axis, and then from there, use your synthetic division. So you'll see you'll see a problem like this on both parts. I'll tell you that now. Step. Okay. So it hits at 1 and it bounces there, correct? So that means it has a double root there, so we have to use synthetic division twice. And I got 1, negative 6, 14, negative 14 and 5, 0, negative 5, let's see, 9, negative 5, and 0. And now we'll use 1 again. 1, -5, 9, -5. So 0, 1, -4, -4, 5, 5, and 0. So now f of x is x minus 1. You can just make it squared because x minus 1 times x minus 1 and then times x squared minus 4x plus 5. And so a is 1, b is -4, c is 5. And I got x equals, opposite of b is 4, plus or minus, got to make, let me make that a little bit better. -4 squared minus 4 times 1 times 5, all over 2. And then what do we get here? 4 plus or minus 16 minus 20. I got square root of -4 divided by 2. 4 plus or minus 2i over 2. And so I end up with x equals 2 plus or minus I. All right, so your roots, you would only need to list the one time, but just we always talked about the rule that there's 4th degree, you have to have 4 roots counting multiplicity and complex zeros. So technically it's a double root. You could list it twice if you wanted to. Not necessary. 2 plus I and 2 minus I. Okay, for that. All right, so if that's on the, you will, like I said, you'll see something like that on the graphing part. Graph it. Don't waste time by just randomly substituting in. Okay. All right, now to find the equation of the polynomial of least possible degree with integer coefficients whose roots are -2 and 1 plus I. Now, I want you to expand this, not leave it in factored form. So you need to write it as, in this case here, it's going to be a cubic, like 3x cubed plus 2x squared minus x plus 5, whatever. You need to write it that way. All right, so we want to figure out our equation. Since -2 is a root, so I got f of x equals x plus 2 will be a factor. And since 1 plus 2i's, I'll have x minus 1 plus 2i. And then I'll have x minus 1 minus 2i. Anytime you have a complex root or irrational with a square root, it's got to have a pair. So there's always got to be 2 of those. I'm going to work with the 2 on the right. I'm not going to mess with the x plus 2 yet. And then I'm going to distribute that negative, and I'm going to make this x minus 1 times -2i, or minus 2i. And then this will be x minus 1 plus 2i. Now you can drop the parentheses and then multiply everything in 3 by 3, but I like to do like the a minus b times a plus b. Treat this as a difference of squares. So this becomes x minus 1 squared minus 4i squared. Well, don't forget, I squared equals -1. I still got to FOIL that. Now this is all one piece, Some people tend to want to put that minus 4i squared at the end. Nope, it has to be part of that. You got to simplify it all together. And so this simplifies to x squared after I FOIL minus 2x plus 1. And then minus 4i squared becomes plus 4. And so you're going to be left with x squared minus 2x plus 5. And don't forget, you still have that x plus 2 in the front. So you get x squared minus 2x plus 5. All right, go ahead and multiply those two together. So you want to finish that. right, let's see here. X cubed minus 2x squared plus 5x. And then, oops. Plus 2x squared. And then minus 4x. And then plus 10. So what do we end up with? F of x equals x cubed. Negative 2x squared, positive 2x cancel. Plus 5x minus 4x looks like it gives me plus x plus 10. So in the end, that whole mess just boils down to x cubed plus x plus 10. All right, so be able to take the roots, give me the equation. Okay, before we took the equation, got the roots. All right, read through this one. This is definitely on the calculator part. Okay. And we did one that this is very similar to one of the homework problems. I think number 85. I'm trying to think what section that was from. Let me look that up. All right, this is number 85 on section 3.2. And this will be on the graphing calculator. All right, rectangular piece of cardboard measuring 22 inches by 38 inches is made into a box with an open top by cutting equal size squares from each corner and folding up the sides. Let X represent the length of a side of each such square. All right, determine the dimensions of the box that will maximize the volume and calculate the maximum volume. Okay, we're going to round anything to 2 decimal places that doesn't come out to be a nice number. All right, so you got a rectangle. Looks like this. We're cutting out a square from each corner. And each square is going to have a side length of X. Original box, 38 by 22. Let me see if that's right. Yep, 38 by 22. All right, so you got to come up with your volume formula. Volume equals length times width times height. All right, now how do I represent that here? What's going to be our length? Okay, you remember? I would do this case, final length. The original length is 38.
38 minus 2x.
38 minus 2x. Okay, so you subtract x from each side. So you're going to end up with 38 minus 2x. Width, original width was 22, but you're taking x off of each end, so it's going to be 22 minus 2x. And the height's going to be x. All right, now you are going to use your calculator to graph this, but to kind of get an idea of the picture, the zeros. What are the zeros of this function? Okay, you don't need to multiply this out. At no point do you have to multiply that out. What degree is it going to be? Third degree. So the reason I say that is some people, you want to use like the vertex of a parabola. It's not a parabola, so you cannot use h equals negative b over 2a. Okay, don't multiply it out. It's not necessary. So the zeros. Okay, so what's this going to look like? 38 minus 2x. Add 2x, divide by 2. Looks like I get 19, right? I get 22 minus 2x equals 0. I get 11. And I got x equals 0, so I get 0. So if I'm just doing a rough sketch, I just want to see what it looks like. You get 0, you get 11, and we get 19. What's going to be the end behavior, though? What's going to be the leading term? It's negative 2x times negative 2x times x. So it's 4x squared, which means it's going to start down here and look like this. Really, what's the only thing we're concerned about? Because you have a maximum amount you can cut out. What's the maximum amount you can cut out of any side to still make this work? Would be 11. You can't take more than 11 off of both ends there, and you really couldn't take exactly 11, but that gives us that end point. So our main focus is right there, and we want to find that maximum value. And so you're going to have to use your calculator to get that. All right, go ahead and graph it. See what you get for your maximum value, and then see if you can figure out the dimensions. All right, and then I'll graph it over here in a minute. Oh, I don't think I ever turned that on.
I wouldn't change the x that much. It is like that isn't my graph is weird. It's just a straight line. Well, I know, but your x. You think about what you see on the x's. We just need to really go to 19 at the most. All right, you got anything on there?
Graph's just.
All right, so you gotta be able to change your window. You gotta be able to change your window. This is part of the test, is being able to work with your calculator to come up with the answer. Okay, so more than likely it's not gonna show up on your screen. You gotta be able to manipulate it so that you can see it.
What you use? Did you just type in those or did you use some fit or anything? Good luck.
Oh, there you go. All right, let me pull up my calculator. Y equals clear. All right, so what do we got? Y equals, parentheses, 38 minus 2x. Oops, I'm gonna need it. And then what else we got? 22 minus 2x. And then we got an x. The reason right here that I wanted to at least sketch this out and find the zeros, what we're concerned about is really only between 0 and 11. To see the whole graph, we got to go to 19 for the x-axis. So you got to have an understanding. What am I looking for on the x-axis, and then what am I looking for on the y-axis? Now, if I go zoom 6, which most of your calculators are probably already in, Yeah, I don't even see anything. Okay, at this point. So like I said, you got to be able to manipulate your calculator to get what you need. So I look here, I go 1, 2, 3, 4, 5, 6. Like, so I said our main thing, or we said our main thing was from 0 to 11. Well, my highest point is 1680 between there. So that's the Y value. X values, negative 10 is fine. That doesn't hurt anything. And since it goes to 19, I'm really only concerned about 11, but I just want the whole shape. I'm going to go to 25 and make that go by 2. Now it said 1680. So I got negative 2. I'm going to go negative 2000 to 2000. Okay, I'm going to put my scale at 200. And then I'm going to take a look at that. So now I see the whole thing. You got the whole picture. You got to be able to get this. Is part of the class. You got to be able to do that. You got to be able to take your calculator, take the table, figure out what the window should be, go from there. Now I need that highest point. So it's not a parabola. So I got the maximum here. And I get 1696. I'm going to go to the 100th, 0.50. So 4.49. Let me do this. So, you know. Oh, come on. Shoot. Oh, there it is. All right. So I got 4.49 is my X. And then my maximum volume is 1696.50 for that one. All right, I do want the dimensions. What's my length, width, and height? So you finish it from there. Okay, so take a look at it. Think what's your length, what's your width, what's your height. Now your length is the 38 minus 2x. Our width is 22 minus 2x. And our height is x. Well, that's just 4.49. Okay. So that's just 4.49. And so 22 minus, whoops, clear. 22 minus 2 times 4. 4.49 gives me 13.02. That would be my width. And then 38 minus 2 times 4.49 gives me 29.02. So that problem, there's a lot going on there. Got to make sure you get figure that out. Now, if you're, after you're done with this problem, you got to make sure you go back to Zoom 6. Figure out your table from there. All right, let's just take a look at this. I don't know if we'll get to the others. We'll just take a look at this one here. Maybe we'll get to the next two. All right, graphing. You got to graph this whole thing. Okay, going through our rational functions. This would be no calculator test, no calculator. Okay, you got to know how to do this with just your calculator. So I got it. for whatever reason, you got the domain and range first. We'll have to come back to those. You get your vertical asymptotes, horizontal, x-intercepts, y-intercepts. All right, think about those. Think about what, and I'll give you a second to go through those, put down what you know. If you're not quite sure, just wait. We'll go through them together. And make sure you label the horizontal and vertical asymptotes correctly in the terms that they got to be an equation. So x equals, and then y equals. Okay, so vertical asymptotes, that's where your denominator equals 0. It's going to be at -1. So x equals -1. And then at x equals +3. So I'm going to draw those in now. -1 and +3. So it's got to be 3 pieces. Remember, you can't cross vertical asymptote. All right, horizontal asymptote. You're looking at the degrees. Okay, Andrew, do you know what the horizontal asymptote is?
Would it be 0?
Why do you say 0?
Because the degree is equal on the top and the bottom.
Yeah, when the degree is equal on the top and bottom, that means you look at the coefficients, leading coefficients. So what would be my leading coefficient on top? If you would multiply that all out, it would be x squared. What would be the number in front of it? 2. And then how about in the denominator? So 2/1. So horizontal asymptote is going to be y equals 2. Okay, for this one. So I'm going to draw that. X-intercepts. This is where the numerator equals 0. Numerator equals 0. Basically, x minus 1 squared. The only thing that's going to make it 0 is 1. So that's, and write it as a point, 1, 0. And now y-intercepts, that is where you plug in 0. F of 0. This might take a little bit of work. All right, what am I going to when I plug in 0? It looks like I'm going to get 2 on top. I'm just going to do it on the side first. And then what about 0 here? That'll give me a 1, a -3. All right, I got -2/3. Can anybody agree with me or disagree with me? Tim, is that yes? All right, so 0, -2/3. So I'm going to put a dot there. 0, -2/3. All right, now I got to make a little bit of a chart. XY chart. I got to pick something to the left of this -1. I'm going to pick -3. I am going to pick -1/2. Plug that in because I want to just be sure what's happening in between this y-intercept and that axis. I'm going to plug in 2, and then I'm going to plug in 5. All right, so take a second, plug in, share the work. So when you plug in 2, when you plug in the other 2. Okay, because we don't know for sure whether that graph will hit that 0 and keep going up or if it'll bounce. Okay, we don't have enough information yet. We got to double check everything. Sam, you got anything yet?
-3 2 2/3.
2 2/3. Okay, so 8/3. 2 2/3 -3. We agree? I don't hear disagreement. All right, anybody got -1/2? Nobody got -1/2? Carlos, you got -1/2?
I got -4.5.
-4.5. Well, unless somebody disagrees, we're gonna go with it. I don't see any disagreement. All right, let's hope you're right. A lot of pressure on them. All right, how about 2? What do you get when you plug in 2? Anybody done that yet? Nobody wants to admit it.
You got -2/3.
Yeah, -2/3. All right, anybody else? Agree? All right, I got one head nod. So we'll go -2/3. And then 5. Oh, what in the heck are we going to get when we plug in 5? It looks like we get 32/12. 32/12, which is 16/6, which is 8/3. 8/3 again, 2 2/3. All right, so -3, 2 2/3. I got -1/2, -4.5. I got 2 2/3. And now we got 5 and 2 2/3. Okay, from here we got enough information to draw this. It looks like it's going to bounce there. And then it's going to come through here. Okay, for that. So now think about your domain and range. Your domain is going to be everything but -1 and 3. Negative infinity to -1. Union -1 to 3. Union 3 to infinity. Our range will go from -infinity to 0, including 0. Union doesn't hit 2. 2 to infinity. So we're missing that chunk in between 0 and 2. Okay, for that one. All right, let's do a little name that graph. One thing you just got to be careful here. The axes have the hash mark on it. Be careful. The vertical and the horizontal asymptotes are not the axes. So my vertical asymptote, that is x equals 2. My horizontal asymptote is y equals 2. Okay, just so you see those, there should be arrows on those. I know there probably doesn't show up. You do have an x-intercept at 0, and you do have one at -4. All right, so think about what the graph would be there. All right, numerator versus denominator. The numerator is determined by your x-intercepts. We got one at 0, and we got one at -4. So the one at 0, you can just make an x. And now at -4, you can make that the factor x plus 4. So you got to have both of those, x times x plus 4. Your denominator is determined by the vertical asymptote. So that is going to be where x equals 2. And so that's going to be x minus 2. Vertical asymptote. Right now, does that satisfy everything? It doesn't. If you leave that, that's not entirely correct. Since the horizontal asymptote is a 2, what does that tell us about the degree of the numerator versus the degree of the denominator? Same or different?
Same.
Got to be the same. Or are they the same right now? No. How can I make that denominator the same degree? Square it. Okay, all you got to do is square that. You cannot introduce something new. You cannot just throw an x out in front, okay, or put another, because there's only one vertical asymptote. To make sure there's only one, you just square that. Now they're the same. But y equals 2. We're closer, but we're not there yet. That means that the leading coefficient of the numerator is 2 and the leading coefficient of the denominator is 1. So to make everything match up, put a 2 out in front there. So now that will satisfy everything. That'll satisfy your x-intercepts. That'll satisfy your vertical asymptotes and the like. All right, let's at least just set up that last one. I don't think I'll get through it. Do I have it? Oh, there it is. The function f of x equals 2x squared plus 4 intersects the horizontal asymptote. Find the coordinates of the point of intersection. Okay, we did one like this last week. But that was last week. What you need to do, you don't need to factor here. You don't need to factor. What is the horizontal asymptote? Horizontal asymptote, degrees are the same. Y equals 2. So that's going to be my y coordinate. So you're going to set 2 equal to 2x squared plus 4 over x squared minus 3x minus 10. And then you're going to solve that. We solved one similar to that, so you should be okay to do that from there. Okay, so we'll set that up. All right, no calculator part tomorrow, graphing calculator, or red calculator part tomorrow, graphing calculator on Wednesday. 60 points each, 120. Make sure you're prepared. Google Meet tonight if anybody's interested, 9 o'clock.